Hi, welcome to section 9.3, which is basically adding and subtracting square roots that are alike. So the cool thing about adding and subtracting square roots, radicals, is basically you treat them as if they were exponents. I mean, not exponents, variables, I'm sorry. So let's say, for instance, this is 2 square root of 2 minus 7 square root of 2. So you treat it as if you would go 2x minus 7x, which you just look at the coefficients of them and then you add or subtract, right? So that would be, negative 5x. So let's say for here, this would be negative 5x, 5 square root of 2. Instead, of course, of x, we write the square root, right? So this is 8 root 2 minus 9 root 2. That would just be negative 1 root 2 or just negative root 2. 3 square root of y plus 4 square root of y. That's just 7 square root of y, or 7 root y. So let's do a couple more. 2 root x minus 4 root square root of x minus 2 square root of y. These are not alike. So you just leave them the way that is. That's just like how it is. You leave it that way. That's the most simplified form. So here you have 5 square root of 13 plus 4 square root of 13 plus 2 square root of 13. That's just going to be 11 square root of 13, right? Like terms. So then 2 root 6 minus 6 root 6. That's going to be negative 4 root 6 plus 3 root 3. We can't simplify this any further. So that's your answer, okay? Because these are not the same radical, and you can't simplify either radical, though. So that's it. Okay, so here, what more examples? We have 2 square root of 5n minus 6 square root of 5n plus 4 square root of 5n. So doing the first two, I have negative 4 square root of 5n plus 4 square root of 5n. These are exactly the same. They're going to cancel out and give you 0. Okay, so here we have, 1 square root of 3xy plus 5 square root of 3xy minus 4 square root of 3xy. So the first 1 plus 5 is 6 square root of 3xy minus 4 square root of 3xy. So then your final answer, 2 square root of 3xy. Okay, so you can also, if you need simplification, we need to be able to just simplify each one, and then if they're like terms, let's see here, then we combine them. So 20, remember, square root of 20 is 4 times 5. That's going to be 2 root 2. So 2 square root of 5, why did I say 2? Square root of 5 plus 3 square root of 5, that just gives me 5 square root of 5, okay? And then here we have square root of 48 minus square root of 75. Let's reduce this. Square root of 48 is 16 times 3 minus square root of 75 is 25 times 3, right? So square root of 16, this is going to be 4 root 3 minus, and then square root of 25 becomes 5 root 3. So your final answer would be negative square root of 3, because we know that the 1 is implied here. When you just, when there's nothing in front, you assume it's a 1. Okay, let's continue. Let's do a few more. 5 square root of 18, 5 square root of 9 times 2 minus 2. Square root of 8 is 4 times 2, right? So this becomes 5 square root of 9 times square root of 2 minus 2 square root of 4 times square root of 2. This is 3, so 5 times 3 root 2 minus 2 times 2 root 2. So this is 15 root 2 minus 4 root 2. And finally, your last answer is 11 root 2. Okay? Okay, so then we have square root of 3/4 times square root of 192. Square root of 192 minus 5 over 6 times square root of 108. So 192, what does that factor into? So that's going to be, let's see, 96 divided times 2, 48, 16 times 2. So let's go ahead and do a little prime factorization deal here. So this is 2 times 96, 2 times 48, this is 3 times 16. This is already a perfect square, and this is a pair of perfect squares. So I can think of this as 192 divided by 3 would give me 64. So this is going to be 3/4 times 64 times 3. So this is so basically how I came up with that, I said, oh, this is a pair, so that's 4. So really this is 3 times 4 times 16, and then 16 times 4 is 64. So then, minus, and then 108 is, let's see here, 108, 9 divided by 9 is what? 108 divided by 9 is 12. So then how about 36? 108 divided by 36 is 3. So then we can say, okay, 36 is the highest, perfect square that divides into 108. So 36 times 3. 3, hello. So then this becomes 3/4 times 8, that's square root of 64, root 3, minus 5/6 times 6 root 3. So it's nice here. 4 goes into 8 twice, so you get 6 root 3. Here the 6's cancel out, minus, and then you're left with 5 root 3. So then your final answer is just root 3. Okay? All right. Let's do a couple more here. How about this one? 9 square root of 50m squared. So this is just going to be 9 square root of 25 times 2m squared, right? So that's just going to be 6. Remember, 48 is 16 times 3. So 16 m squared times 3. I just moved the constants over. It doesn't. So these are the perfect squares here. So 9 times 5m square root of 2 is left. And then here 6 times 4m square root of 3. So then you have 45m square root of 2 minus 24m square root of 3. And then your final answer is 45 minus 24. That's 21m. Oh, actually, we can't even do that, right? Because we don't have like terms. So that's what happens. So see here, this is a root 2 and this is a root 3, so we cannot combine them. So we can just leave it that way. Or you can leave it as, yeah, that's pretty much, yeah, usually, yeah. Could we have written, to some people might say, well, can't you write 45 root 2m? Yes, but just make sure that it's very clear that the radical is only above the 2. So that's why usually you put the radical at the end. All right, let's do this one here. So 2 times, and then we have 4. 8 is 4 times 2, right? So x squared times 2. Here, I'm putting the perfect squares together. Minus 5x. 32 is 16 times 2. Plus 5 times, and then you have 9, and then x squared times 2, because it's 9 times 2 is 18. So then fine, let's keep going to this, this part here. The square root of that is 2x, and then you're left with root 2 on the inside, 2 on the underneath the radical. And then here you have 5x times 4 root 2 plus 5 times, this is perfect square, 3x square root of 2. Okay, good. So let's go ahead and simplify. 4x root 2 minus 20x root 2 plus 15x root 2. Since these are all alike, we can go ahead and combine them by adding or subtracting the coefficients. So we have 4 minus 20, negative 16 root 2, x, negative 16x root 2, sorry, plus 15x root 2. So then finally you're going to get 1 negative x root 2. Okay. Alrighty, so that's it for 9.3. Pretty short. Good luck. Here's your homework. Happy studying, and I will see you on the next video.